Now let us take this problem 29 of your textbook. Problem 29 of your textbook says that a car moving at a speed of 36 kilometers per hour. So we have to do it. First we convert 36 kilometers per hour is equal to, we know, 10 meter per second. This is the velocity. And with this velocity, the car is taking a left turn in a circular path. And the radius of the path is 50 meters. The problem says a small wooden plate is kept perpendicular on the seat. This small wooden plate is kept perpendicular on the seat. And a small block of mass 100 gram. This is the small block of mass 100 gram. 100 gram. And we also write that mass equal to 100 gram is equal to 0.1 kg. Kept on the seat, resting against the wooden plate. The small mass is kept against the wooden plate. Now, the friction coefficient between the plate and the block is 0.58. Also, we write mu is equal to 0.58. Find the normal contact force exerted by plate on the block. Now, when the plate is perpendicular, then normal force applied by the block on the plate is only equal to mv square by r, because there is no other force available here. It is only equal to mv square by r. So the first question is question A. Normal force equal to m v square by r, which you can also call centrifugal force, is equal to m is 0.1, g is 10, so 10 square, r is 50 meter, is equal to 10 by 50, this is equal to 0.2 meters. This is one. So next it says the plate is slowly turned away from the block. That means plate is now slowly turned towards right, away from the block. Now what will happen when it turns away from the block? A time will come at an angle theta when this force mv square by r, or a component of this, will try to take this block up along the slope. The paper setter only wants to know that find the angle at which this phenomena starts. So in order to find out that, we draw the force diagram. Say this is the angle theta at this angle the body starts going up. Let us say the body is here, right? Then this is the force mv square by r, mv square upon r. This is always horizontally or radially outward. Now this force will have two components. One is upward, other is in normal direction. If we complete this parallelogram, then it will be easy to remember, right? Now, if this is theta, then this force is mv square by r cos theta, and this force is m v square upon r sin theta. Sin theta. Now there is a friction 0.58 between the block and the wooden block. So if this force tries to take the block upward, there will be a friction mu n. And what is n? N is nothing but opposite force of mv square by r cos theta. So this is mv square by r, mv square by upon r cos theta. mv square by r into cos theta. Okay. So from here we get this is equal to n. From here we get n is equal to m v square upon r cos theta. Also we get mu n is equal to this force. That is equal to mv square by r sin theta. From here what we get? We get, if you divide this one equation by other, let us say we do mu n upon n, then mu n is mv square by r sin theta, that multiplied by small n is r will go to the numerator and mv square cos theta. On either side, you will find this m gets cancelled, r gets cancelled, v square gets cancelled, n gets cancelled. So what we have? We have mu is equal to tan theta. That means tan theta is equal to mu. The value of mu is given is 0.58. Now, if you use your calculator, you will find theta is equal to 30.11 degree. This is the answer. Okay? Now we go to the next question, and this will be the last question of this chapter. Says a table with a horizontal surface revolves in a circle of radius r. The same thing. This table, it revolves and the radius of revolution is r. And there is a smooth pulley and there is small m, there is a m2, and it is given that the smaller one is m, the smaller one is m, and the bigger one is 2m. This is given in the equation, m and 2. Now, initially, the masses are held with the string pointing outwards. That means somebody holds these two masses, pointing them radially outward so that the strings are taut, and then the revolution starts and it is released. What will happen in this case? Because to solve this problem, understanding what will happen is very crucial. If you don't understand what will really happen, you cannot solve this problem. When this happens, when it will start revolving, Both these masses, due to their centrifugal force, will try to move. But this one has a greater mass, so this will move direction, and this one has a smaller mass, this will move in this direction. And since they are tied by the same string, obviously acceleration of both of them will be same. This hence onward, this problem looks like a kinematics chapter problem. So if we do the free body diagram of the smaller block, we find this is the smaller block. This is the smaller block, and the string will be always under tension. The string will be always under tension, and the tension T, because the string will be always under tension towards right? So this is the T, and the smaller block will left side, because this is small. So on the left-hand side, there is a force MA. Also, on the left-hand side, there is a force equal to the centripetal force. Just I have to erase it. On the left-hand side, there is a centripetal force which is m omega square r, which is equal to m omega square r. So what is the equation here? Equation here is force balancing equation. Equation here, T is equal to m omega square r plus ma. Similarly, take the free body diagram of the larger mass. Both diagrams are similar, only their motion or acceleration or MA is in opposite direction. This is 2m actually mass, and here also this tension is in this direction, and the centripetal force 2m omega square r. Once again, I have made a mistake. Arrow is in north direction. Arrow is in the radially inward direction, 2m omega square r. But here only the force to create acceleration is in the opposite direction, and that is 2ma. Right? So here the force equation is T is equal to 2m omega square r, 2m omega square r minus 2m. Now you just equate equation A and B. If you equate equation A and B, what you find is m omega square plus ma, m omega square r plus ma is equal to m omega square r minus 2ma. Now if you bring ma terms on the left hand side, we find 3ma is equal to only m omega square r. You cancel m on both sides. Therefore, what you find, A is equal to omega square r by. This is the acceleration they want. Find the magnitude of the initial acceleration. This is found. And also they want to find out the tension of this thing. They put this value in any one of the equation. So we write from equation A, what we get, tension T is equal to m omega square r plus m A is omega square r by 3. So this is equal to 4 by 3 m omega square r. This is the answer. So this is one answer. This is the second answer. Fine. So this completes our chapter of circular motion. Next day, we shall go to the next chapter.